Welcome to General Structures 2 and Lateral Forces Lesson 3 quiz, question number 2. And it says, which statement is correct for the truss shown below? And it has A, B, C, and D. And before we even look at A, B, C, or D, let's take a look at this truss. And I went ahead and reproduced it here. And I guess some things that we can know from this truss are, well, it is symmetrical. So real quick, you should know, or hopefully you should know, that 5, actually, the way I would look at it, I would say 5 plus half of this, 2.5, so this will equal 7.5 kips. This will equal 7.5 kips, and you should do, maybe you add all three of these together and divide by 2 since it's symmetrical. Either way, that's what you'll know. What else do we know? We know that these two loads right here, or these external loads, are not they're not being loaded at a pin, or at a panel point, as you might want to call it. So these are all pins. That's another thing we know. And so these two are not being loaded, so that's going to induce moment into these connections right here, and we'd have to design for that. Another thing we know is that this is a zero force member. And, oh man, I don't think we ever went over zero force members in this section. We may have, and I didn't look at it. Let me take a quick look. Zero force member, method of sections. I don't think we went over zero force members, but there are certain ways you can figure out what a zero force member is without even actually analyzing this truss. And you would know this because you could say, well, how do you know that? You've got this 5 coming down here. And the answer is, the more you work with trusses, the more you'll be able to pick these things out. And if you open up a General Steel's book and you go through truss analysis in a steel book and a steel class, you will go through these zero force members. So let's say you're doing method of joints, and eventually you get to this point right here, and you cut it right there. So you're looking at joint D. So you're going to have that coming straight up. This is how I end up drawing things at times. So you are going to have the force of DC. That's going to be in the X direction only. You're going to have the force of AD, and then you're going to have the force of BD. And you also do not have any external forces at joint D. And hopefully you can see that. Well, knowing what we know and going through truss design and method of joints, you try to look at what's in the X and Y directions. Well, right now you can't figure out X and Y. We know that F AD is going to equal F DC, and they're going to be in opposite directions. We'll put that in correct opposite. So they're going to be either both compression or both tension. And I can tell you right now, this is just what you're going to think off the top of your head. Oh, well, they're equal and opposite, therefore if they're both coming in, then they both have to come in. Or one of them's coming in, they both do. They're both one coming out, both have to come out. But we know that they're actually going to be in tension just based on what we know about a simple span. These are going to should be in compression, and this should be in tension, just like if you think about a beam. If you have a regular beam, this bottom flange is going to be in tension, top flange is going to be in compression, because it's going to try to bend like a smiley face, and therefore it's crunching that. So I'm not going to get any further into that thought process, but hopefully you understand what that means, and if not, go through some of my older stuff, and I'll do a lot more videos in the future. But anyways, let's move on. I think I've got my point across. And where we are at, we are saying that FCD, but if you look at FBD, there's nothing in the Y direction to counteract that. These don't have Y. FDC doesn't have a Y component, FAD doesn't have a Y component, and FBD doesn't have an X component, so FBD equals 0. Because there's nothing equal opposite, and you can't if you did have the one way this FBD wouldn't, and you have to watch out because sometimes when you're just starting out, I remember I did this. This could, you'll say, oh, that's a zero force member. I see it's perpendicular. This is 90. This is 90. That's perpendicular. This is a zero force member. But if you have a load, say if you had a 5 kip load right there, that would automatically become 5 kips. That would not equal 0 anymore, and it would not be a zero force member. So just so you see that coming. So we know FBD. This is about all we know. And I'm going to go ahead and move on right now because I said quite a bit, actually. So I'm sure the answer is somewhere in that explanation I just gave. So let's go on to A. The force in member BD is 0. Okay, BD equals 0. We said that. So that's correct. And members AB and BC should be designed for combined bending stress and axial. Yes, because they're not loaded at a panel point or at a joint. So yes, A is seemingly the correct answer. That's exactly what I said, and yes, that's perfect. But let's go on and make sure that something's not more perfect, which I don't think there's going to be. Okay, let's go on to B. The force in member BD is 5 kips, and members AB, so we know right now that's incorrect because BD is not 5 kips, and it says, and members AB and BC should be designed for combined bending stress and okay. So the second part of that's true. The first part is false, and therefore it is false altogether. All right, let's go on to C. The force in members AD and DC is 0. So it's saying AD and DC is 0, and members AB and BC are in compression. I'm assuming that those are in compression. A, B, and BC are in compression, but I do not think that B, A, D, and DC will be 0. Those will be positive. And if you think about it, this will be in compression, therefore you're going to have something coming in, and it's going to have this type of components, and therefore that's going to introduce a X component to this A joint, and therefore you're going to have something coming tension force in that AD to counteract it, and therefore you're going to have the same thing over here, since we said they're equal opposite, and really the same thing's going to happen right here. This is going to be in compression. So hopefully you see that. Anyways, that's the incorrect answer. Members AD, DC, and BD have equal internal forces of 2.5 kips each, and we also know that's incorrect because we already said that it is a zero force member of FBD, and therefore it's incorrect. All right, I hope that helps, and I will see you on the next question.